Last week, we learnt about two types of distance sensors, ultrasonic and infrared. There are two other types of distance sensors that can be used in robotics. They are laser sensors and camera sensors. The laser sensor is similar to infrared, but where an infrared light that we can't see, shines around a robot, a laser sensor sends a really tight beam of light in one single direction. Think of the difference between maybe a light bulb in your house that shines light around the room. That would be the infrared sensor. While a laser sensor would be similar to a torch, where you shine the light in a very specific direction. And then you wait for that light to bounce back. That light that bounces back can be detected, and the receiver on the robot is so sensitive, it can measure the time that light took to travel forward, hit an object, and bounce back. And, same as last week, if we know the time that light traveled, we can then measure the distance. Another really amazing thing that we can do with these laser sensors is shoot lasers all around a robot and then wait for that light to bounce back. Once it knows the direction of those lasers and how long that light came back, it can see the distance of all the objects in an area around it. Pretty cool, huh? We spoke last week about how animals and humans, with eyes at the front of their heads, can send those images to our brain, and looking at those two images, we can detect the differences and measure distance. But that's really complicated. But as computers have become more and more powerful, programmers have now started using that same idea to take pictures around a robot and work out the distance just looking at those images. It can even combine this information with the laser distance sensors to create a depth camera. These sensors are starting to be widely used with drones and even driverless cars. Let's have a look at how a distance sensor can work with a normal car. The distance sensor used in this example is an ultrasonic sensor, which you were introduced to in the last chapter. As sound waves are sent from the car, these waves bounce back off any objects in front of the car, and when the distance of the object is too close, the controller in the car can tell a speaker where the driver is to start making a beeping noise. This way, if you have left a skateboard or bike in front of your car at home and the driver didn't see it, they will know to stop when they hear beeping noises. When a car is reversing, you can use the same idea by placing ultrasonic sensors to the rear of the car, and the same beeping noises will occur, letting the driver know to stop. Let's try activity